All right, so in this section 2.7, we're going to learn what a basis is and how to determine the dimensions of a basis, or even the dimension of any subset as well. All right, so let's start with a definition. A basis for a subspace H of Rn is a set in H that is both of the following. Number one, linearly independent, and number two, spans H. So I'll say and. All right, so a basis for a subspace of H is a set in H. So our basis is going to be in H, but this set must contain linearly independent vectors, and the things in our basis must span all of H, meaning we should be able to write everything in our basis. We should be able to write everything in H as a linear combination of things in our basis. So let's look at some examples so we can see what this looks like. All right, first example, let's say we have a subspace and it is the span of these two vectors. All right, and this is a subspace of R3. Okay, so remember, things in H can be written as linear combinations of these two vectors. All right, so the first thing that we need to check, because I'm going to hypothesize that we could just use these two vectors as a basis for H. So the first thing I want to check, just these two as a set, are these two linearly independent? Definitely. You can't write one in terms of the other. So number one, these columns, 1, 0, 0, and 0, 1, 0 are linearly independent. Great, one thing on our list. Okay, next, does it span? Of course. Of course it spans because everything in H is the span of these two. So everything in H can be written as a linear combination of these two. Therefore, these two form a basis for H. All right, and so the way we would write our basis is as a set, because it is a set. All right, so what we're saying when we say that these two together as a set forms a basis for H means that we can get everything in H just from using these two vectors, and this is all we need. All right, question, there are only two things here, which means it's not going to span R3. That is totally fine. So our basis does not need to span all of R3. All right, let's look at another example. Let's say our subspace H is the span of the vector 1, 1, and negative 2, negative 2. And this is a subspace of R2. Okay. So let's check. Could we use these two vectors as our basis elements? Well, these are not linearly independent. Therefore, these two do not form a basis for H. However, because you can write one in terms of the other, you could choose either one of them and it would be a basis for H. So the set with just 1, 1 is a basis for H because just this vector by itself is definitely linearly independent. Also, everything in H can be written as a linear combination of 1, 1. And we can say the same for 2, 2. Also, a basis for H would include, negative 2, negative 2, and any other scalar multiple of these. So also, 5, 5 would work. So we can have multiple bases for a subspace, but they do need to be linearly independent and they must span the whole space.